Our first question is to determine the future value of each amount deposited into a daily savings account. Now, the word daily savings account means that the interest is compounded daily. So we go to our first question and it says $400 in an account that pays 1.05% per annum for the months of May and June. So that means it's compounded daily, since it's a daily savings account. So we begin our solution by doing a typical compound interest response. Our initial amount is $400 and we don't know our final amount. And our little letter I is 0.0105 divided by 365, which is 0.000028767. Our little variable n is equal to 61 because there are 31 days in May and 30 days in June. So n is 61. So we enter all of this information into our formula. A equals P times 1 plus I to the n. The principal is $400. 1 plus I is equal to 1.000028767 raised to the exponent 61. And our final answer in this situation is $400.70. So that's the future amount of $400 deposited in a savings account. So we see that savings accounts, generally speaking, don't really provide too much in the way of interest, but they are convenient for getting money out whenever we want. Our next question asks us to determine the future value of $3,200 in an account for 2 weeks that pays 1.8% per annum. Well, 2 weeks means that our exponent will be 14. Our principal value is $3,200, that'll be P. And we'll have to figure out what little letter I is. It's going to be 0.018 divided by 365. So we write our solution. P is 3,200, A is question mark, I is 0.018 divided by 365, which is 0.000049315. N is 14, and so we create our equation. A equals P times 1 plus I to the n, and we see that A is 3,200 times 1.000049315 to the exponent 14. We evaluate our exponent first. That's what BEDMAS tells us to do, which is $3,202.21. And finally, we have $100 in an account for 1 day that pays 1% per annum. Well, in this case, we know our principal value is 100. We know that our little letter I will be 0.01 divided by 365, and our exponent will be 1 because it's only in there for 1 day. When we're doing daily savings accounts, our exponent will equal the number of days. Well, our principal value is $100. Our little letter A, or excuse me, our A is unknown. Our little letter I is 0.01 divided by 365, which is 0.000027397. So we put all of that into our formula with an n value of 1 because it's 1 day. And we see that capital A will equal 100 times 1.000027397 to the exponent 1, which is 100.003, which means we don't even get a penny of interest. It gets rounded down to $100. So after 1 day, we still don't have any interest. But after our second day, we would actually get rounded up to 1 penny. All right.